All right, so good evening, everyone. Thank you all for joining us in this session. So it doesn't really matter if you're just getting started with your journey in astronomy or you're already well versed with it. In this session, we aim to clarify all your doubts that you have related to it, and also explore and also show you the world of all the possibilities and opportunities that we have in astronomy. So we're really lucky to have a panel of four really profound and educated eminent speakers with us. So starting off with Dr. Gaurav Waratkar.
Yeah, I'm not a doctor yet. Clarification. Almost there, but not yet.
Okay, so who's currently about to go for his postdoctoral research at Caltech and is pursuing his PhD at Starlab IT Bombay. His areas of expertise include gravitational waves and also high energy astrophysics. Next up, we have Dr. Next up, we have Dr. Praveer Tiwari. He did his PhD from Washington State University and is currently pursuing his postdoctoral research at Starlab IT Bombay. His expertise includes supermassive black holes. So then next up we have Mr. Yogesh Wagh. He's currently doing his PhD at Liverpool John Moores University, and his expertise will include near-Earth asteroid detection. Moving on, finally, we have Mr. Sameer Patil. He has had 25 years of experience in technology in various firms like Google, MSI, and Morgan Stanley. And now, finally, since the past year, he's been working at IT Bombay Startup to pursue his interest in astronomy and astrophysics. So, can you please have a round of applause for that? And also, one thing before I hand on the mic or the stage, this is going to be a very interactive session. So, I would highly recommend you all to and encourage you all to ask all your questions because truly, getting an opportunity like this to ask your questions to them is something you probably might never ever get. So, please, I really encourage you to ask your questions and get your doubts clarified. So, thanks.
Okay. So should we introduce? Okay. All right. So my name is Sameer Patil, and yeah. So my journey is going to be the most probably unconventional. You can say crazy, but I graduated from ITBHU in 1997. It was not yet IIT at that time, and in computer science and engineering. So at that time, astronomy was not really on my mind. Really, I was, going with the flow of what was popular or what was new and upcoming at that time. And that's why I chose computer science in college. And then it led to a career in technology industry, and I enjoyed it thoroughly. But somewhere, astrophysics was there on my mind. I used to, do online courses and have my own telescope, and I used to follow it. So it used to be a hobby, and I really had not thought it could become a profession. But somewhere in the last few years, somehow my thinking changed, and I thought of doing something different. And I also happened to meet a few people who had taken different career choices in their 40s and 50s. So that gave me a little bit of courage. And so I started exploring if I can really pursue, a career in astrophysics, like doing some serious research work. And fortunately, so last year, I tried applying, and it was not easy for me to get in because of my background. I did not have any experience in astrophysics at all. But some cold emails helped. At that time, I had applied to IIT Bombay, but I could not get through. And Gaurav was part of the, the admission, the selection process. Somehow I found his email ID, and I just sent a cold email, and he was kind enough to reply. And I got to talk to him, and I asked him how I can, get really involved in astrophysics, and he gave some suggestion. Krittika was one of those, right? And I did a project with Krittika. At the same time, I also sent some cold emails to professors at TIFR, and one of them was, keen to use machine learning in the cosmology work that they do. So that was another break, and I worked with them for 1 year. So yeah, over the last 1 year, I got some good experience at TIFR, and then I applied again for IIT Bombay, and this year I got selected. And so I've just started my journey into astrophysics in a serious way. So yeah, I mean, after so many years in technology, now I'm looking forward to exploring this field. That's my journey so far.
Go next. Yeah. Hi folks, I'm Gaurav Waratkar. I'm a final year PhD student here at Starlab IIT Bombay. I entered this campus in 2015, so a decade-old guy in this campus. I did my BTech from here, BTech in mechanical engineering. Exactly 10 साल हो गए अभी. July 2015 I entered. This is August 2025. Started in mechanical because of the love of cars, so I joined IIT Bombay Racing. But in my first month of IIT Bombay, I also attended the orientation like everyone does in PCSA. And then I saw Krittika's video and I absolutely loved it. It is one of the worst videos now, but it was one of the best videos back then for me. I loved it so much that I wanted to do it. I attended all the events of Krittika in my first year, so much so that I attended more than the conveners do. In my second year, I went into IIT Bombay Racing. I was a junior design engineer there, working in powertrain, designing gearbox for the electric vehicle that we built. In my third year, I went into this dilemma. I wanted to do astro, I wanted to do mech, but I never had the astro research background to select if this really is the thing that I want to build a career in. So I was like, BTech is for exploration. Let me give a year to myself. Let me dive into some serious research. I did that in my third year. I unfortunately loved it as well. So here I was at the turn of my fourth year that I loved mech. I loved astro. So I was confused, kya karna hai? So I was like, let me keep my options open. Fortunately, I got a fantastic project with Varun here. Varun Alarao is the head of Starlab, where I could do a bit of both, a bit of physics research, so astrophysics, which was something that I loved. At the same time, I could do mech as well. I was given the task of leading the engineering for an upcoming space telescope called Daksha. So I was going to build a satellite with him. So that was a very lucrative offer. I took it. I started my PhD in Jan 2020, and in the past 5 years or so, I have been a part of several research projects. I've worked in a lot of collaborations. I've studied black hole mergers, neutron star mergers. I've studied gamma ray bursts. I've also studied fast radio bursts. I have studied gravitational waves. I've built software for them. I have also designed the hardware for Daksha, the space telescope. And overall, that has been my journey. The dilemma that I carpeted during my BTech of not choosing something haunted me back again during my last year when I was like, oh shit, I have to choose again now. And I was spoiled with more choices because I was doing almost everything that Astro has to offer apart from theory. I was doing some level of computation. I was doing some level of physics. I was doing some level of hardware development as well. So I thought to myself, what is the thing that really gave me the best kick? And that was actually having something tangible in front of me that I have built myself, and that was the hardware. I applied for only those positions which gave me this experience in future, and I fortunately got selected for this postdoctoral fellowship that I'll start next month at California Institute of Technology, where I'll be working with Space Radiation Lab there, working on a NASA mission, hopefully. So that has been my journey from a BTech guy wanting to build cars to now building satellites. It was a great journey. I got to do a lot of research in between. I got to mentor a lot of students as well. I got to teach a bit as well. So it was very fulfilling overall. I'll use the cliched line of saying that I was on the other side. And I always had this dilemma of what to do next. And I believe that we will always have this dilemma because we always want to hit our ceiling and want to find out what's the best thing out there for our potential. That's a lifelong thing, and it's okay to feel confused. I'm confused as well. We'll figure it out together.
Go next. I'm little overwhelmed with all the very interesting journeys that these people have. I I frankly speaking, my passion for physics was right from class 10th and 12th. So there was not a choice in terms of what I want to do, and there was never a confusion in that respect. But um, when I joined ISC for my bachelor's and master's, like it was a dual degree, uh, because we were the first batch, we were like spoiled kids, right? Like our seniors were doing PhDs and masters, so there were huge, age gaps. So we were like pampered quite a lot. So so much so that we used to just stroll around ISC departments, and then whatever research we found interesting, we used to just approach the professors or like research students, and we actually were actually be entertained. I mean, usually if you go in any institute, people usually say that okay, you have to send an email and so on and so forth. But being the spoiled kid that we are, we were just taking advantage of that. So for my second year, I visited one of the labs called computational fluid dynamics in aerospace department. So that was my first research project. We were developing numerical algorithms for partial differential equations. And for next 3 years, I did just that. And then for my fourth year, for my bachelor's project, I did an accretion, like simulation of accretion disk around a supermassive black hole, using my expertise, so to speak, that I gained using the computational fluid dynamics background. Then for my master's, I approached International Center for Theoretical Science, Bangalore, where I switched to gravitational waves. So we did some data analysis work there. And for my PhD, then I moved to Washington State University. There, again, uh, I joined because one of the professors there were working on gravitational waves. And as soon as I joined, he went to sabbatical. So, and since it was a very small group, physics department, most of the people were condensed matter. And the next best thing that I liked was machine learning. So I just searched which professor worked on machine learning. So there was one professor who was trying to apply machine learning in condensed matter physics, like hydrogen systems and stuff like that. So I joined his group. For 3 years, I developed potentials for a hydrogen system, hydrogen crystals, and then we were trying to reduce the time taken to solve Schrodinger equations using machine learning. And then he got another. So in US, there is this concept about the project that you do highly depends upon the funding that you get for it. So my professor got a funding in again a condensed matter project, but that simulation did not involve machine learning. So I was like, I can't see myself working in condensed matter physics. So the only reason I was a part of the project was because it has machine learning components. So then I decided to take a brave step of switching that like research uh, from condensed matter physics to again back to gravitational waves. Even though the professor that I planned to join was on a sabbatical, he graciously agreed that to guide me. So for next 3 years, I did my PhD in gravitational waves. So I was the only person in his lab to speak. So it was like a 10 by 10 cubicle, and I was the only person. So that scene actually haunts me still, but that's something that we need to overcome. So I overcome that, and then we developed some models for neutron star equation of state. So to understand the composition of neutron star, we did some model development. And then I submitted, and then also I used machine learning to develop gravitational waveforms and stuff like that. So that was my PhD. And then after doing my PhD, I decided to move back to India. And then again, yeah, there also because it was a forced thing that I had to come back because of my family reasons. So I then decided to move away from academia, and the reason was purely my this feature that I think I was not very aware about the notion that how this research group works. So because we were like my previous encounter was in ISC where people had this notion that okay, this is the best research institute, and I was not aware if other institute have uh, that level of maturity of handling a research project or something of that sort. That was my naive. So I applied to exactly two positions for my postdoc, IIT Bombay and ICTs. So that is the only two positions I applied, and then I started applying in industry. And so I just sent a mail to Archana. She is my current colleague, and then she responded, and then we talked about what research I could do. And simultaneously, I also had this offer, so to speak. It was fourth or fifth round. I don't know which one. There were lots. So apparently now industry have these multiple rounds of interviews. So I lost track of how many rounds I gave. So then that was a fintech or something. So apparently the financial technology guys, they need physics people to do some sort of stochastic modeling. So yeah, so then as soon as Archana said, yeah, you're fine, you can join. And then I actually had interaction with her when I was doing my project at ICTS. So yeah, so it was no brainer actually. So I was not expecting that I'll get a postdoc with Archana, and fortunately that she accepted. And then I, from the past 2 years, I've been doing data analysis for neutron star systems and then eccentric binary black holes. And I'm finishing this August, so I'll be moving to Chennai Mathematical Institute for my second postdoc, where I'll be working on stuff like testing cheap general relativity and stuff like that. So that's my overall career till now.
Yeah. So I'm Yogesh Wagh. I started my bachelor's in mechanical engineering in BJTI, which is in Dadar. So before BTech, I thought as everyone thought things कि कौन सा branch choose करना है for engineering. There were a lot of options, but I hated coding because JavaScript जो 12th में होता है, it was very daunting. So I chose mechanical, and my path from there was what Gaurav did. During my second year, I joined this club, which is VGTR Racing Club, and we helped our seniors with building of a all-terrain vehicle. We helped them with manufacturing and designing of some components. During third year, I got to lead a team of 24 students. Most of them were my classmates, and that was one of a kind experience for me, and that was highlight of my engineering days. So I basically designed, manufactured a car from scratch within duration of 1 year. And that was highlight for my mechanical engineering and nothing else, because grades were great, and I loved physics from the start. So I couldn't think of any way to get into physics because I was in my fourth year, and I think fourth year में सबको यही होता है कि which company they are going to get placed in, right? So I had that issue, and I wasn't sure कि मुझे industry में जाना है, like mechanical industry में जाना है, or I need to do physics or not. Starting में जनरल physics पसंद था, like pop science translates to your love for physics, right? So I didn't have anything in mind. I applied for a few competitive exams that you have for getting masters in IITs or other research institutes. I gave those, but didn't really score enough to get into those universities. So I went with the second option, which was a job. And the job wasn't great. It was good for mechanical. It sounds good, but it wasn't that good. It was in JSW. So I was assistant manager for a coke oven plant, and you guys must have seen the KGF movie, right? So KGF movie में वो एक fiery scene होता है on top of a roof. That was my plant. So it doesn't sound very interesting, right? I mean, to work there is not so much interesting, given the kind of things we did during the car making. So so I worked there for 1 year. My job initially was to build a coke dry quenching plant, and I helped them assemble the whole thing. And we did that. We tested it, and it came out to be great. We started with the production, and the very daunting thing for mechanical guys is that mechanical maintenance is very what I think it is very repetitive. So as soon as the whole plant starts, every component will start breaking down. And earlier, so earlier stage, it was very interesting as everything was new to me, how to fix things and all. But it sounded repetitive after 3 or 4 months, and the whole thing was getting monotonous, and I lost interest in those things. Like I didn't see myself doing these things for longer period of time, so I thought of switching again. And so one of the things that happened during BTech was I got to attend one of the mega science exhibitions that we had in Nehru Science Exhibition, Nehru Planetarium. That we had an exhibition. I was part of it, and I got to talk to Archana Pai and Varun Palera. I got to talk to these professors, and one of their PhDs mentored me to like what things you should do to get into IIT for your masters in physics, and later on you can decide what field do you get interested, what field interests you. That you can decide later. So that thing had stuck in my mind, and I decided to leave my job after 1 year and chose to. Then I appeared for IIT Jam, cleared it, got into IIT Bombay. For first year, I thought of exploring every field. So I did a small project in nuclear physics with gamma ray spectroscopy. I did one of the summer schools with Krittika club, and which interested me. So my astronomy my interest for astronomy grew there, and I decided to approach Varun Palera sir, and he agreed to take me up on a project. The project was related to detection of near-Earth asteroids. So there are millions of asteroids hanging there in the belt which is beyond Mars. So some of them may be hazardous to us because their trajectory might intercept with trajectory of Earth, the way it goes. So the challenge is to detect these asteroids using one of the telescopes our lab has, Star Lab, which is called Growth India Telescope. It's a fully robotic telescope. You can get astronomical astro images, science images, which are useful for astronomy, doing any kind of astrophysics. So one of our seniors, one of your seniors, Kriti Sharma, she was also a mechanical engineering student, and she built a pipeline called Asterix. So it needed a few tweaks, and I started working on that. So I developed a few things there, made it more automated, and that was my first project, which was to observe an asteroid and to make sure if it is an asteroid that we haven't discovered before. So that was my first project to start with astronomy, and I managed to discover or to contribute discovery of 45 asteroids so far, asteroids and comets, and those are never seen before. So that was a kind of inspirational thing to me that helped me motivated to stay in this field. In the fourth semester, which is my last semester for masters, I did more towards physics, which was gamma ray burst afterglows, to study those. and do some programming to that will help us model. So whatever observations we get from these GRBs, we can model them and we can tell them what kind of parameters we had associated with that GRB. My master's was completed, and after that, I got an opportunity to work with two professors abroad. One of them is from NASA, and another was from University of Minnesota. Both of them are one of the best people I have seen. Like they have built many astro-related softwares, which you guys might have used before or might use in future. So I got to work with them, and the project was related to to make a scheduling algorithm for any telescope to observe these events. So as Gaurav mentioned, he worked on gravitational waves, and he is also part of LIGO Association, Science Association, Science Collaboration. Yeah. So uh, other so these events come to us as a probability sky map, and we want our telescopes to decide what part of sky we should look first. And that is the algorithm I built, helped them build, and the project is completed now. And during this process, I was applying to PhD positions abroad, and I got into LJMU, as you guys know, and I'll be joining them during October of this year. And that is my journey. So far.
Right, so now please feel free to ask all your questions that you have related to these topics or anything in general about how you want to proceed or we're coming to the tests.
How does it feel like when you observe the merger of two black holes?
Feels awesome. Yeah, I mean, if you see black holes, they don't emit anything, right? Do they? Yeah, so they do emit some level of complicated radiation that we don't understand enough. But if you have two black holes and they merge, they emit some level of radiation which Einstein predicted 100 years back. It's called gravitational waves. It's gravitational radiation that comes out from these mergers. And it took us 100 years. It took us rather 30 years to build some of these detectors. They are sitting in US right now. The third one is being built in India, LIGO India. These LIGO detectors, which are the gravitational detectors, they can detect these gravitational waves. These are not optical or rather electromagnetic waves, not your radio or X-rays or optical or anything. They are gravitational waves. They cause changes in space-time. If that is a thing that works for you. So if a gravitational wave is passing through me and this camera, then the distance between me and the camera will change by a very small fraction, and the small fraction is smaller than the than 1,000th of the diameter of a proton, right? So it is smaller than the change in the ocean level if I pour one bucket of water in it. So it is a very small change, and that's why it took us like 30 years to build these detectors. Not us, as in I didn't build it. I wasn't alive back then. But this was a major engineering marvel. So there's a lot of engineering that went into building this detector, which finally made it possible in 2015, because of which the core people who were behind this, they got Nobel Prize for this. So when these mergers come, they create some level of detection signature on your screen. You can't see it because if you would have been seeing it, then we wouldn't have invested millions of dollars in building that. But it is the kind of engineering that you have to do to make these detections possible is incredible. I thought I knew. Okay, I was a part of LIGO for about 2 years, and before that, I knew about LIGO for about 4 or 5 years. And I thought I knew enough about LIGO and the detectors until I went there last year. And I actually saw the instrumentation and the detectors and everything that they have done, and it blew my mind. I was there for 3 months, and I came out more confused and with less information than before. but it is incredible to see these detections happening. The other sets of radiation that exists from binary black holes are that there are certain models that predict that you can get X-rays from it, you can get ultraviolet light from it, you can get optical light from it. And these are very, very difficult to observe because these binary black hole mergers are not happening in your solar system. They are happening billions of light years away. So the radiation that will come from them is going to be incredibly faint. So you'll need very good telescopes, the best satellites out there. So, which is why IIT Bombay is trying to build one called Daksha. So, all of that is very, very difficult thing to do, but it feels awesome when you do.
What can be the expected daily life of a scientist? Like, what is there a proper schedule, or like you have to work without info or something like that?
Yeah, I mean, so it is different for different fields, but the core ideology is for doing research. I mean, that's my ideology, and I'm not imposing anything. But if you are waking up in the morning and you are excited to go to the lab, that's something which is precious, which not many people get. Even if, for example, there will be days where you are frustrated that you have not figured out things, or you're not understanding some of the results that is there, but in your heart you will know that okay, the struggle that I am doing currently is worth something. And it can be true for research, it can be true for any other field that people are excited by. But if you are doing research, it becomes very important that you have that kind of motivation, because I mean, you're doing something which is not existed before, and you should be taking pride in that. And that's something. And I'm not talking about research in physics in general, but research in any field that applies. So if you talk about a daily schedule of a researcher, I would say that it's something which is highly volatile. On some days you will work from say 7 a.m. to 9 p.m. because you want to get some things done, or you want to find what is wrong. But on some days you want to also take your health seriously and then try to take rest, take a step back, because a healthy mind is something which is very important, and you cannot compromise on that. A good diet, a good schedule is very, very important, but that does not mean that you are how do I say, you are burdened by it. I mean, I've seen people doing 9 to 5 research, and they are doing very nice research. I've seen people doing 7 to 9 p.m. research, 7 a.m. to 9 p.m. research, and that is also very good. But at the end of the day, when you are sleeping at night, you should be satisfied. That's the goal. Otherwise, you will be frustrated.
Maybe you would also benefit from knowing that there's a bit more flexibility in academia that will be in your hand. So you have a bit more controls. So essentially, you will be answering yourself most of the times, and it is very easy to fool yourself and go to sleep at night. So you'll feel that you have done a fantastic day during your week, and
only to find out next week it was
only to find out next week that your professor is pissed. But in industry that is a bit more robustly understood and monitored. He will be able to tell you that given his 20 years of experience. In academia, though, that comes with benefits and its cons as well. You get the benefit of choosing when you want to wake up and when you want to go to sleep, which is 4 a.m. at night, and you would want to wake up at 12 p.m. and so on. But that also leads to a lot of self-imposed deadlines that you would end up missing, right? So if you are very good at being disciplined, academia is going to reward you a lot. The consistency that requires to solve a problem over the course of 5 years is It's not a sprint, it's a marathon. We are usually in BTechs and masters, we are usually trained to do a lot of sprints. Every assignment is a sprint, every end sem, every mid sem, every deadline is a sprint. PhD is completely different. You won't have any sprints, you will have marathons and marathons. And the consistency in that is what Praveer was also saying, that your consistency, if you are being healthy, mentally healthy, physically healthy, emotionally healthy, everything matters over a long stretch of time. That flexibility comes in handy. At the same time, it can also cause some level of damage to your end result. You probably must have seen this. Professor will give you a deadline 2 weeks from now, but tum last day hi karne wale ho, right? So that is the consistency is not there. It is sprints. So if you're wanting to get a flavor of research, joining a professor and matching and meeting all of the deadlines that the professor and the research group expects out of you is a very good way to get some level of flavor of research. And then extrapolate that for 5 years, then you will find yourself in the shoes of a PhD student or a postdoc or any academic. Maybe you can add about the industry part.
Yeah, sure. So I think you explained very well how you work in the research industry. In the research and in the industry. I mean, I've spent many years, and definitely just because now I have left industry and in the research, I don't want to make it like totally black and white. But as I think Gaurav was nicely saying, there are sprints and there are marathons. And in industry, actually, we use that term sprint, right? I don't know if you have heard about the agile software development and things like that. So actually, we use a term like sprint, which is you have very defined goals for a short period of time, and you need to achieve those goals in that period of time. So 2 weeks sprint or 3 weeks sprint, etc. Having said that, it's not like in the industry we don't have long-term goals, but we do. But yeah, I think we are dominated by the sprints and being able to deliver things on time, etc. Whereas I think as Gaurav was saying here, there are marathons. You have some long-term goals, and you need to achieve some deep impact in that long term. But I guess sometimes you may also be driven by something which happens in the short term, right? There is like gravitational wave detection and potential gravitational wave detection, right? And then everybody's analyzing the data and everybody wants to, and then you may have a short time frame to come up with your analysis. So, yeah, there may be some flavor of that short-term work over there. But yeah, I think overall what Gaurav said probably summarizes it of sprints versus marathon.
So I'll add just 1 minute of context to the sprint that we was mentioning in the academia. So the gravitational wave detections that we do, they come up with huge sky maps. Like Yogesh worked in his last year, he developed codes that very optimally schedule the pointings of your telescope. And why is this important? Because each telescope pointing costs you several hundreds of dollars, several thousands of dollars if you are working with larger telescopes. What happens is that these alerts go out to the community within seconds. Yogesh's phone was ringing, popping up with notifications while he was sitting here because he's on duty to monitor these alerts right now. Yeah, he was looking at that right now as we speak.
This is the kind of sky map you get.
So this is a all sky, as in you are looking at the sky, and then all the red spots that you are seeing is the higher probability of a gravitational wave merger being present there. Now your task as a telescope operator or a telescope user is to point your telescope to cover all of these parts so that you can find the counterpart, is what we are calling it. Counterpart as in the gravitational wave, the black hole mergers, the binary neutron star mergers. When they merge, they give out gravitational waves, but at the same time, when they explode, they give out X-rays and other optical light and so on. You want to catch this. And this is, I'm sending out alerts to all of you. It is essentially fastest fingers first. Whoever gets the first photons from this particular patch of the sky is going to get that discovery to their name. Now, this is a race that goes on across the globe. It is not within IIT Bombay or within our country, it is across the globe. And the photons are not like कि मैं बस मुंबई जाने वाला हूँ. They are going to go everywhere. Now, you want to be the first there, and that is when you would want all of your algorithms, all of your supply chain to be as streamlined as possible so that you get the first photon and you get the discovery to your name. Now, why is this an important thing? This particular event that I'm talking about happened in 2017. There have been over 1,300 research papers that have happened, that have published so far since then. It is equivalent of one research paper every day. One event will give you 1,300 research papers. एक research paper से PhD हो जाता है. Okay? So the amount of science that you can do in some of these fields that in which we are working in, it is called transient astronomy or time domain astronomy. It requires some level of these sprints. Because if these alerts go off at 3 a.m. at night, it won't be like, oh, Indian Standard Time mein abhi night ho raha hai, so we'll come back tomorrow morning. It's not like that. You'll have to wake up. You'll have to get this data analyzed as soon as possible and publish it out to the world. Which is why we have built a lot of automated robots, rather bots that can get us this data without us having to wake up. There's a lot of things that we have been able to do to address these sprints. But these sprints also exist in academia. At the same time, marathons also exist. And they are very rewarding. They are very rewarding if you are into some of that. Yes.
So I used to love astronomy during my school days, and during my bachelor's I got carried away, and my dream was something out of the academy and all. So now I'm here, and I feel like I have the opportunity again to explore this field further. And I'm a complete rookie in this area. I don't know much. So where should I start? I mean, what are the course subjects I should be focusing on, and what are the seminars class I should be focusing on, and where should I start?
So I think, I'll start with the fundamental stuff, and then you can add more. But the fundamental physics courses are all, useful, right? So whether it's mechanics, quantum mechanics, classical mechanics, etc., electrodynamics, these are the fundamentals that you need to build. And then on top of that, it will build some knowledge of astrophysics. And within astrophysics, there are a lot of specialization. So, for example, there is observation related work, there is data analysis, there is cosmology, and then within astrophysics, you could study different types of astrophysics like galactic or stellar or things like that. But I think the fundamental physics courses is where you should start.
I think from my experience, I think Introduction to Astronomy and Astrophysics is a course which you should aim for. So the reason I'm saying is that, as you pointed out, that there are lots of specialization that is happening, but what interests you or what you want to work on might differ. So an introduction course will allow you to gauge what is the thing that interests you, and then based upon that course, you can go for specialized courses in whatever field you want. So yeah, I will stress upon taking astronomy and astrophysics.
Currently, you are
First year master.
masters. Okay. And you did bachelor's in
Physics.
physics.
Yeah.
Okay. I think there are a few courses and masters in physics, right?
Yeah, master.
First year. Okay. So you will come across a few courses in like electromagnetism in your second semester, and also there will be one course taught in your third or fourth semester which is related to radiation physics. Those courses helped me a lot in my research during fourth semester and so on. And it also builds a foundation that you can translate those things to your research directly here. Well, any physics you are doing here. So the courses here during first two semester, what they cover is enough for you to jump onto the research directly. So I think that's the thing. You do not have to worry about like selecting special courses. During third and fourth year, you get a choice if you want to pursue career in condensed matter. So you select courses related to those. Astro related courses are also there. Advanced Introduction to Astronomy is also there. So you get a choice. So you do not really have to worry about like what courses you should focus more on.
So I quickly add this answer this question as a intro to anyone who is starting. So if you're just wanting to get a flavor of what Astro is about, what you can do is you can approach it in the traditional way. You can go and do courses, and the courses that IIT Bombay offers that will get you started with Astro without going into the specifics of it is a course called Intro to Astro, which is going on right now. So it happens, I think, Tuesday and Friday, or Thursday and Monday. Monday. Varun Waratkar is taking it, and he's a great instructor. So you'll get to learn a lot from him in that course. So that's a great intro to Astro if you're wanting to get into some formal training in Astro. Now, for those who missed the course deadline and course adjustment deadline and were not able to sign up for this, I think the deadline is over, right? So yeah, you can do a bunch of things. First, you would want to get a understanding of what research is out there in Astro without diving into it and investing 6 months in it, right? Astro is so vast and so huge and so diverse that there's so many things happening at the same time in different fields. So you would first want to get this flavor of across the globe what kind of research is happening in what field, be it in X-ray, radio, optical, infrared, gravitational wave, cosmic rays, neutrinos. You speak of any sort of astrophysics, you'll find a lot of physics concepts being used. So do you go and approach all the courses first and then start doing your astro research? That's also a way to go about it, but it will take you years and years to go. So what I usually recommend people to do is that there's this one series called Astro Bytes, which are bite-sized, as in 2-3 paragraph long summaries of research papers that students like us and academia's researchers all across the globe, they publish in international journals. And what they do is that they compress it down, condense it down into 2-3 paragraphs, which are very easily accessible and readable and understandable by newcomers. And it is also involved to a level that you will be able to understand it right now. At the same time, you'll be able to still benefit from it at a stage where you are like an advanced researcher. So, for example, I still read Astrobytes to get a flavor of what is happening in other fields, despite starting in Astro almost like 9 years back. So, Astrobytes, definitely look it up. There's this astronomy picture of the day that NASA has. There's a series called from NASA. Now the picture is a pretty picture, so don't just keep looking at the picture. You'll also find a good description of that particular picture at the bottom of that particular Insta post or the website that they have. Go and read it up properly. It is written for extreme newcomers, so anyone will be able to understand it. And if you don't understand, there will be links that will be given in the caption of that particular post. So that got me started with some level of observational astro that really helped me out in understanding, this Hubble Space Telescope has these many filters, and cool, what is the use of these filters and so on. So that is the other thing that you can do. The third thing that you can do is, you are in an academic institute, and go and talk to people who are actually doing the research. So you can just one fine day randomly drop in by Starlab and just say that, hi, I'm interested in Astro and I just wanted to get a flavor of what kind of research you guys do. And more often than not, most of the people will be more than enthused to get you at least a taste of what all of us are working on. So you can come by, for example, Starlab anytime. You can go by their lab at any time, and they'll be able to show you in person that what kind of things that they are working on. And the last thing that you can do is, the department and the professors and the research groups here, they keep on organizing a lot of talks and a lot of seminars. What you can do is you can go and attend these seminars. 90% of it is going to go over your head. They still go over, it goes over my head even after doing a lot of research in this field. Doesn't matter. You go there, sit at the front desk and ask them questions. If they throw you out of the seminar, that's okay. They are not going to remember you the next day. We'll edit this part out. But the thing that you will benefit out of it is that you'll be asking first, you'll know and understand what kind of questions you would want to ask. Then you'll find out what kind of questions are these researchers asking to get their research done. And it's a very good stepwise process that you'll keep on doing always. Don't get shied away from doing these things from your side. People will be there to help you out.
So I am a mechanical freshie as well, and I wanted to ask how much of the mechanical part do you use when doing research and all?
Maybe
so hardcore mechanical जो designing and manufacturing वाला experience directly translate नहीं हुआ, but so during my mechanical engineering days, I took this course called CFD, Computational Fluid Dynamics, and I use MATLAB to simulate a few systems, like write a code and simulate how things will change. So transient analysis of a pipe which contains hot fluid, how the temperature of pipe will change with radius and all, how the pressure within the pipe will change, and this helped me to like how to approach a problem, problem solving skills basically, and coding also, because you are making algorithms, you are writing algorithms, right? And I think this experience helped me directly to start with my first project in Starlab, which was coding based only. And what is your question, Bhaiya?
How much of the mechanical part does it come in handy when
the subject knowledge is what you're saying, right? The courses that you're doing, how much of it that is going to come in handy in research?
Yeah, it also depends on what project you will be working on in astronomy or astrophysics. For example, as Gaurav mentioned, he got an opportunity to, I think some designing part you did, most of it, in Daksha. So you do component designing for the entire satellite, right? For entire space telescope that we are sending. And along with that comes analysis, structural analysis, thermal analysis, and all sorts of things. So I think your experience will not be like wasted in any sense. Any kind of experience you gain during your mechanical engineering days will be translated to your research further in some sort of ways. And he had one example. In my case, it was coding, solely coding, because I didn't really have anything to do with mechanical during my projects, right? So, do not really worry about like if this is going to be useful or not. I think some part of thermodynamics you might use in astrophysics. Like there are some systems like magnetohydrodynamics. Their fluid dynamics can be useful, and in some cases it is relativistic. So physics and fluid dynamics both is involved. So it is a mixture of many things, and you will find it yourself कि कहाँ पे क्या apply हो रहा है.
For example, I did a project in computational fluid dynamics, and then I went on to do a project in physics in simulating the accretion disk around supermassive black. So it helps. I mean, it sometimes depends upon what you want.
And I'll quickly add one thing there. One is that if you're doing your bachelor's in mech, the courses that you're learning, let's say some equations, Bernoulli, if you're learning there, you won't be able to use all of it as it is in every other field that you are going. I did my BTech mech, but I used a lot of the work that I had studied in my mech research in my astrophysics PhD, right? So it was never really useful for me in my physics research. But they are right in saying that some level of fluid dynamics is one of the things that overlaps well with the astrophysical systems that we are studying here. The thing that I will say is that the subject knowledge is not that important, but the mentality that you take from every course to dissect down every problem to the concept and then building it from that stage is something that we still use to this day to understand better about any problem, any source, any new thing that we are observing. Uh, that is still used. So some level of uh, understanding of how to break down problems and that will definitely come in handy no matter what you're doing in your life in the future is what my understanding is here. Uh, if you go into any sort of PhD, usually PhD first year in any course in any program out there in the world will give you enough insights into enough courses at your hand to get you trained to that level where you will have understanding of almost all concepts in that particular niche that you're going in. So if you're going in PhD in astrophysics, then the first year courses that you will get will train you to that level of understanding everything about radiation processes, ISM, high energy physics, and whatnot. You'll have that basics sorted by the institute in which you'll eventually go and do your PhD. That really helps you out, and that brings everyone to the level playing field, no matter what your background is. If you're going from physics to mech and wanting to do a PhD in mech, everyone will benefit out of that PhD coursework and come to that almost same level. And yeah, that will help you get started with the subject knowledge part of it.
And I'll just add a couple of things. One is if you're doing PhD and you want to have these introductory courses, then US is something which you would want to like prefer because Europe PhDs are mostly project oriented. So you join a project and then you do a PhD on that. So there is not many university which allow like which has a rigid framework of 1 or 2 years of coursework, 1 or 2 years of coursework. So yeah, so that is what I think. Second thing, as I was answering, I forgot my point, so I'll just refrain from
Yes. So can the people in like industry or job field also do the same or like similar work as in the academia? Or it's very different from that? Okay, maybe I'll start then. So I think it depends on like what is the motivation or what is the driving factor. In industry, the driving factor is going to be what the customer wants, right? And that will translate into actually what your manager wants, right? But essentially the base driver is what the customer wants or what is the market need, and based upon that your industry project will be decided, and that translates down and it boils down to the engineers who are working there. In the academia, I think the drivers could be slightly different. It could be what the larger set of problems that the global research community is trying to solve, and then maybe when it comes to you for a PhD student or a research postdoc, it could be what their professor is guiding them towards, right? So yeah, so the driving factors are quite different. But then ultimately, I think you work with your immediate supervisor in both cases, and you decide what is the right, course of action for yourself.
So I can add one thing. So for a specific case of data analysis part, if you're doing a data analysis based research, then it's very similar to what people do with data in the industry. So you have these time series data that you want to find patterns from. So the tools that you develop in one can be useful in the other part. So that's I'm specifically talking about data analysis part. And for example, if you look at fintech, so they use pattern finding algorithms that is related that is armed from stochastic differential equations, and you do use stochastic differential equation in your physics research and stuff. So those things can overlap because we are in a data-driven economy. But just for data, this other thing I'm not sure.
Okay, like particularly astrophysics related field.
Yeah, so astrophysics. So, for example, gravitational wave data is like you have a time series data that is coming from the LIGO detector, and you would want to mine out the signal. Or why do you want to mine out signal? Because you want to characterize the source. Similarly, industry counterpart would be to find out what are the patterns of stock. You have these stocks, right, which goes up and down, and then you want to find out the patterns in there and then predict what would come after. Similarly, so those type of data mining is something which can be the tools that you develop to analyze both of the things can be exchanged. I mean, you can add. I would like to add
A small thing that you get a lot of photographs from telescopes, right? And there are some cases where the photo is crowded with stars, and your interest will be in one particular star and not the stars surrounding or galaxies surrounding it. So there are a few image processing techniques that you build. Also, as I mentioned, one of my first project was near Earth asteroid detection. There also I used image processing to extract the potential NEOs, the asteroids in the image, right? I think these skills can be useful in, say, what do we call it? Auto-driven cars, automatic cars. Yeah, that or cancer detection in medical systems. There they will use ML algorithms for that, but image processing will still be there. So these are the kind of skills that are transferable to industry directly. I think you'll come across more as you explore them, but yeah, these are some of the fundamentals to do with image processing or data analysis or data science.
Sir, how is NASA citizen science project for a newbie to know if astro is for me or not?
They are great to get started with some level of sneak peek into what kind of research projects are. These citizen science projects are usually for people who want to dedicate some of their time to benefit the bigger project that is happening out there. So sometimes you will classify galaxies, you will identify objects within images and so on. These all are used as inputs into a big classification learning algorithm at the cloud, which then will be used to publish some level of research paper on and so on. There have been examples of people actually discovering some objects using these citizen science projects, so that it is really cool initiative.
They do asteroid detection kind of thing and
Yeah.
galaxy classification. So, will it? I mean, does it helpful to know if if I join that project, and so will it be helpful for me to know if going into astro is helpful for me? Going into astro is for me or not?
Yeah, so it will.
As a career.
You're right. You will get some level of flavor of what kind of astro research is, but it is not going to give you enough insights into the nitty-gritties of the nuts and bolts of a particular machine that you are wanting to build. So, for example, driving a car won't let you build a car. You will be able to understand where the car is going and what kind of a bigger picture understanding of what the parts are, but you won't be able to build it by yourself. So you will only be able to do it when you go and dive into serious astro research. Citizen science projects will get you access and get you actual real data experience with the kind of things that you are already doing. So that's a very good first step, but there are several steps beyond it which will get you that answer that you are looking for.
And one more thing, I want to know about astronomical instrumentation.
I can answer that. Astronomical instrumentation is essentially all kind of engineering and instrumentation that you will build to construct these telescopes, these satellites, these observatories that will eventually do a lot of the science that we are all talking about. So if you want to detect a very faint object, which is which is billions of light years away, you would need you can't put your phone and look at it, right? You will need extreme level of engineering for that. So you want to build telescopes, you want to build satellites, you want to build observatories, and it is essentially it entails everything from mechanical, electronics, signal processing, uh, some level of software engineering as well. All of this combined into one is what is roughly termed as astronomical instrumentation. Um, in my experience, I have dealt with two of these. One is I I have been building the satellite with the help of ISRO here at IIT Bombay. So I looked into everything about mech of that particular satellite. When I was fortunate to go to LIGO last year, I was able to help out with some level of vacuum and seismic engineering that they do at these sites. So there's a lot of small tasks that will come in. That there's a lot of large projects that you can come up with. Overall, astronomical instrumentation is essentially building anything that will support this science that physicists are doing. So you will be able to get your hands dirty that through any level of mech or elec or software and systems engineering is what astronomical instrumentation is about.
PhD person वो काम करते हैं या PhD in astrophysics or astronomy is different from
जो बॉस बोलता है वो करना पड़ता है. Anyway, so yeah, you will converge onto the topics of your PhD with your professor. I was telling at the start of my monologue, I was a mech student and I wanted to do both mech and physics, so I wanted to bring in some element of mech in my PhD, which is why I worked on astronomical instrumentation in a very grand scheme of things. Okay, I did mech design of the upcoming space telescope that we have here. You can involve. So, for example, my professor, he worked on satellite with NASA during his PhD, and he worked on the calibration of detectors and the detectors that are put on that space telescope, and it is launched. He worked on calibration and screening of those space detectors, the X-ray detectors that he has. So that is also some level of astro instrumentation. So your PhD can have multiple things that are coherently combined under a single umbrella. So my umbrella was high energy transients. So I studied transients and I built instruments to study them better. For him, my guide, he also studied high energy transients, and he also built satellites that can study it better. So similar, just in different countries.
Yeah. I just wanted to add on this that currently LIGO India is like building a new detector, and they would want lots of people with this mechanical and electrical background, and it's a very starting phase of the detector building up. So if you are to get involved right now, then it will be good for LIGO India as well, and as well as for you, because currently there's a huge push in that direction, and there's lots of openings. And people, we want people to learn about how to build detectors and how to maintain them. So once the detector comes, so just to give you a background, the detector is like 4 kilometer by 4 kilometer. It has 4 kilometer arm on either side, and you have to maintain a vacuum chamber around it, and then you have to monitor around 4,000 to 5,000 sensors. So he was not kidding when he was saying that it is a state of the art. And we want people to get involved in this, get your hands dirty in this type of engineering, so that we have the expertise in homegrown expertise of these detectors. So that's kind of quite cool, and people can get involved. So
Government of India approved something like 2,600 crores for this mission, for this observatory to come up here in Maharashtra itself, in Hingoli district. So it is a very cool opportunity for anyone who is wanting to get into gravitational wave or any level of instrumentation. So the engineering folks, this is up for you. Go and talk with Archana Pai's group to find out more about this and the details of what exactly you can do right now. What kind of courses can you take up to become eligible for these roles? What kind of PhD institutes can you use or select in order to get trained in future and come back here and build Taigo India for India?
What are the ways in which a person from remote sensing and geology background pursue lunar geology?
So, can you repeat the question again?
I am personally from remote sensing and geology background. So, in what ways I can pursue, or what are the scope in lunar geology?
Lunar geology.
Yeah. What Desigo? Yeah. So basically, currently, when a gravitational wave comes, right? So you have gravitational wave coming from binary black holes, right? And binary black holes or any sort of gravitational wave source enters into different phase. When it enters, when they are very very far away, the frequency of the gravitational wave that they emit is quite different than the frequency when they approach, when they are very close. So currently, the ground-based detectors that we have, they operate in a very specific, they are sensitive in a very specific frequency range. That means they can probe that system in only at a particular state. So now what the plan is to take this whole 4 kilometer by 4 kilometer detectors to I think move and dark side. So and for doing that, we would want to know what kind of noise sources there are. I mean, here itself, when we build it at ground, we would want to characterize what kind of source there is. So in one of my visits to LIGO detector, there was a truck passing by like 2 kilometers away, and the guy in the situation room, we call it situation room, control room, right? So they was like, okay, this is because that truck is passing by. So we need that kind of sensing it at ground itself. Same type of characterization are required when we are building it at near the moon, and so we would want such.
You can detect sea waves that are clashing against the rock near the sea, several hundred kilometers away at your LIGO site. So these detectors are so sensitive to any ground movements because you are essentially trying to detect ground movements between the 2 mirrors that you have at the end of each arm. The thing that these guys are, I don't know if it is approved or not. The mission called Desigo is trying to build is some level of gravitational wave detector at Moon. There's one more mission called okay, I forgot the name, but it is a radio telescope that is being proposed to be launched to the farther side of the Moon, because that side of the Moon is radio silent completely. You don't have any sort of radio interference, and that will allow you to probe a lot of cosmic background, and that will allow you to understand and probe the level of cosmology that has never been done before. And it is an Indian mission that is currently proposed to be launched. So that is another closest resemblance to anything that contains the word lunar in our dictionary right now. But if you are talking about lunar geology, it is a question worth asking the planetary science folks. There are missions that India itself is launching. You know better than us about it. Several payloads on board Chandrayaan have probed a lot of these things. So that is the closest that it comes to astrophysics. A better question would be for planetary science folks, none of whom exist in IIT Bombay, unfortunately, in physics department, unfortunately.
How realistically doable it is to initially have a tech or market related job or be in that field and then transition into the research field or academia related to astrophysics.
So a transition from engineering or any other field to astrophysics at any stage of life, or are you talking about some particular niche specific thing?
Let's say for generally and in which other stage?
Okay, so there are multiple stages: post BTech, post masters, post PhD, post BTech. Okay. Yeah. Sameer did his transition.
I mean, I have proved that anybody can come into research when they want. But obviously, I mean, you should plan wisely. Like, if you already have some plans, right, then maybe you can plan it accordingly. But as such, I don't. I mean, I've kind of proven that there are no such restrictions or barriers. My BTech was in computer science and engineering, so I didn't even have the knowledge of physics that a mechanical engineer would have. But I think the programming knowledge helped me kind of do that, find that bridge. Programming and AI ML expertise helped me find that bridge. Uh, so yeah, I think that if you have made up your mind, definitely you can find ways. But I think if you already have something, a plan on your mind, I think you can plan your steps accordingly.
More specifically, I think also when you are reached as you put lot of effort in actually reaching out to people who know how to get it, do that transition. That's also very important. So yeah, so you have to find the right people to help you do that transition. I think that's more important because currently we have lots of channels that you can go to and you can become competitive. So you need to be more informed about what field you want to go in and what is the correct path to to make that transition.
I'll add one thing. Any transition or any pivoting that you do in life is not easy. It is at times sold as a cool thing that people do that, yeah, I pivoted later in life. It is not easy. Okay. So he proved that you can do it, but it is not easy. I transitioned from mech to astrophysics. It was not easy because I was literally competing with people who have done their all of their coursework in physics, trained to do a lot of fundamental physics. I was not trained to do that. I was trained to build. I was trained to build things. Whether you want to transition into something, what kind of pitfalls you'll face in the future is why he was saying that go and speak with people so that you can prepare yourself accordingly. If you need to do some level of courses during your BTech, if you want to do a minor in physics before jumping into astrophysics, that's a possibility. If you want to do a research project before jumping into astrophysics, that will give you a good insight into it, and then later you can decide. But if you're specifically asking about if you want to do a job for a few years and then come back into academia, he has done that after 20 years. You can do it after a few years as well. It will just distance yourself. You'll end up distancing yourself with academia at some level. So you'll first will have to convince your employers that yeah, you would want to do this and you're not scamming them. You are really wanting to learn and do a PhD, and at the same time, doing a PhD is you are going to take a hit in multiple aspects of your life. You will take a hit most importantly financially. If you are earning decently in industry, PhD will offer you enough to support one person and a family at max if you're very modest in your expenses. But essentially, consider that as that your PhD will be able to fund yourself through those 5 years. At times, it can take even 6 years. So when you're starting a PhD, don't think of yourself as a 22-year-old who is just out of this campus and is able to live in a hostel. So I'll be able to survive on a very modest stipend. Think about yourself when you're 28 years old, when you're about to finish your PhD, because you'll have almost like 5-6 years of your almost same stipend wala life. You'll have to go through them while your peers are earning like lakhs and lakhs per month and so on. So there's some level of financial hit that you will take. So keep that in mind. There's some level of you will be traveling at times. You will be away from your home. So that some level of flexibility there as well takes a hit. It is close to industry. It is not very different, but still try to keep those things in mind. At the same time, when you are entering your PhD, think about yourself not just financially when you are 28, but also in your personal life, what you would want to be, where you would want to be, at what kind of responsibilities would you have at the age of 28, 29, 30. If you're starting at 24, you'll be 30 when you're finishing your PhD. So, thoda plan about the future so that you are prepared about it, and then nothing hits you as a at the last minute when when you can't sign out of it.
So how did you convince your family, like you were in the fourth year and you make a transition from mechanical to astrophysics? So you just leave your instant job and like you were totally career was totally risky, like nothing was decided. So how did you? What was the scenario at that time?
I'll answer that, but Sameer had to add something to the previous question.
Just on the previous question, and you raised a lot of important concerns. Another concern would be where in your career graph you will be at that point in the industry. Let's say you have achieved certain level, and then when you come to the research field, then you may be starting afresh, right? So at that time it may bother you, right? So just think about that as well.
I've heard a lot of people saying to people who are coming out of their PhDs or postdocs that you're overqualified for any role in our company. So how can we employ you right now? Because it won't be fair for you to go and join as a fresher. It will be. I'll take offense to that. It won't be fair for you to go and join in the shoes of a person who has also spent like 6 years in a company, because it will be offensive to them. And so on. So it is very difficult for companies to understand at times the kind of exact place of a PhD student or a postdoc in their company. That being said, situation and things are changing in industry as well. People are wanting more and more of these problem solvers and not one trick ponies. They want people who can do a bit of everything, and people in startups, for example, or in the newer fresher companies, they would want a lot of faces who have done some level of academic training, which is essentially a PhD, so that you can go and solve problems for them which they are not able to solve. So your overall skill set, not the codes that you are writing, but the skill set that you are building around those codes on how to actually go and crack that particular problem, is the thing that people and companies look for. And as long as that is matching with the kind of trajectory that he was saying, that if your PhD is fitting well with the kind of trajectory that you are imagining in your mind, then the PhD jump is worth it and it makes sense. Yeah.
And on top of that, if you still want to, like after a industry job of 4 or 5 years, and then you do PhD, and you want to remain in PhD, remain in academia as a professor, you should also think about this thing that research institutes here have these age limits for getting into professor positions. So for example, most of the positions are like 35 years of age. After that, it's very highly unlikely that you get a associate professor position in a research institute, for example. But you can still join a research position at a different institutes. But yeah, so those things need to be in US. I don't think that type of age restriction is there. When I was doing my PhD, a person joined who was 38 years, and he joined as a PhD student, and he was qualified for taking up professor positions. But in India, there is this age barrier that is there in some research institutes that you should be aware of.
I'll add one last example to that particular question. You can go from industry to academia, and that also brings in some level of expertise to your skill set. For example, if you are interested in mech, go and join a mech company and do the kind of work that you were hoping to do. Understand the industrial mindset, the kind of problem solving that comes in when you are in an industry is fast paced, like he was saying. At the same time, you're expected to deliver at a bunch of places. But the most important takeaway that you can take from industry is that you will be only looking for problems that exist in the society, and you would want to solve them. You can take that approach, you can take that knowledge, and then go and join your PhD, and then try to approach or try to look for problems that are tangible and solvable, and that will bring in a different mindset during your PhD. It will make it fast tracked as well. I've seen it. I have several examples that I can give you offline of people who have actually done this 2-3 years of jobs and then switching into a master's or a PhD. That has given them a lot of push and a lot of perspective in their careers. You had asked a question before we jump to that.
So I was just talking about the transition, like what was the scenario at that time? That means you have this instant job at that time, and you just turned yourself into a career, like you have just no financial support from that career. So I think I'm going to confused in that same situation that you were. So
is this a question specifically to me or
probably to?
So for me, I'll answer that the reason why I took my PhD was because of certain personal decisions that I could take. I had some financial freedom, because of which I could take the plunge of not supporting my family for 5 years. And at the same time, there were certain other reasons that I could take up this PhD. In terms of my professional growth, I could see this as a very good match of what I wanted and what I was getting. Elsewhere in the world, I was not getting any of this, be it in a company, in industry, or in any other PhD place. So it was sort of a no-brainer for me. I also came in with the mindset that once I start earning, the money factor might be a bit more lucrative for me to come back to academia. I don't know what my mentality would have been had I taken that plunge. It could have been other way as well. But my thought process back then was to finish up the things that I really want to do. PhD was a degree that I really wanted to finish ever since the start. But apart from my transition, I think some of the transitions that these guys went into is also very important. So
yeah. So as I said, as I mentioned, that I worked at a company, at a steel manufacturing company for 1 year. So I had to think a lot because I won't be getting any paychecks anymore, and whatever savings I have to put them into masters, take a risk, and later on, my earning source will be PhD, which won't be enough. Like it will be enough to sustain myself, but not my family. So it's subjective to everyone. Like it's very subjective. It varies person to person, but in my case, it was enough. Like the plan was not robust, but it was enough for me to take a decision of leaving industry right now, and later on I'll be earning 2 years or 3 years after. Masters is for 2 years, likewise.
So I would add to that. I think if you want to do this transition, like lots of people that joined me during my PhD, what they did was they did this 4 to 5 years of industry job, did some savings, and then went to PhD in a US university. And the advantage that you get from there is that you get 3 years after doing PhD. You will get 3 years of time to decide whether you want to stay in academia or you want to pursue industry, and then your industry the industry experience that you have before counts a lot when you're applying for industry in US. So now you will have a more flexible option of whether after PhD if you want to stay in academia or if you want to pursue industry. So that is something. If you want to stay in India, I would say that you follow them, but for US that's the scenario.
Yes, so we have to wrap up right now because it's getting.
I think we'll have one question.
So flipping the situation, you mentioned a lot of cases where people have flipped from, let's say, industry to astro, right? As you start a career in astro and you've done your PhD, what are industries that will value your skills outside of astro? What options do you have there?
Yeah. So as I said before, for people who are working as a data mining people or data analysis people in astro, they are very valuable in industries like financial technology and the data science that we have, but there is something called as boot camping that people do. Like there is a specific 6 months course that people have to transition from academia to the industry. Specifically, not in terms of skills, but in terms of the softwares that people are currently using to apply those skills. So those kind of when you're doing a transition from industry to academia to industry, then these type of like packages and technologies you need to know before actually doing some things.
Maybe I'll give you some surprising something examples, but I know a lot of people who did PhD in physics and they have joined companies like Morgan Stanley and other financial firms, where there are a lot of these quantitative jobs and analysts who need to create models for market phenomenon or stock prices or things like that. And the modeling and numerical experience that they bring from the physics PhD, they utilize that. So that may not be the mainstream example, but I've seen many people utilizing those skills in such industries as well. But in general, I think the kind of skills you develop in problem solving and things like that can be easily transferred to industry.
I can add a couple of examples there. You can go into data, big data, or any level of data science role. You can go into quantitative researchers or a role where you can implement your algorithms that you have learned and maybe invented during your PhD to be used in these trading and benefit these companies. You can go into, for example, moving away from the coding platforms. You have done a lot of modeling in your PhDs. Typically, you don't have always done that, but if you have done that, then climate science is a big upcoming field that is hiring a lot of PhDs who are good at modeling stuff. And you're working with SkyMaps, you can work with maps on Earth as well. So that is something that you can work with. Image processing that Yogesh was talking about, there's a lot of companies that want to train use images to get a lot of things done. I won't go into the specifics of it, but what astrophysicists do, they work with a lot of data. So the kind of algorithms that people astrophysicists deal with is going to be immensely of use to these companies, which is why you will find industry connections with some of these professors that you'll find in general. So go and approach your professors if they know of any companies who have approached them, and then you can go and transition into those companies. Same goes with instrumentation as well. If you're into instrumentation, there is good space startups in India. There's good amount of established space companies in India. As at the same time, outside India, there's a lot of good ecosystem that exists where you can naturally seamlessly transition into, provided you start that groundwork well before you jump into that transition. Right?
Yes, I think we have to wrap up for now. It's getting pretty.
You can ask a question later on this class.
Yeah, and as Mr. Gaurav said, you could just visit Starlab or any of the labs to get a nurse lab. So, finally, I would like to thank our panel for sharing their experience and their advice. I would like to thank you all.
One of the most important things that I believe all panel members emphasized on repeatedly was getting to know people with shared interests, with shared likings, and with shared situations like all of you. Because a lot of you are facing different situations, and it is important to be a part of a community that is willing and able to discuss these things. So when you attend events like these, which we at Krittika conduct to fundamentally to bring people together, we believe we are able to at least get towards some semblance of a community in IIT Bombay, and we believe that the updates for these events are something that we are able to put out regularly on our Instagram page. The ID for this is krittika.iitb. So I would urge all of you that if you want to get more information about events like these and various other kinds of events, including things from stargazing sessions, please do follow our Instagram. You can also do that by scanning the QR code here, which I'll be putting on this table so that you can just scan it when need.
Nice, awesome. Thank you everyone for coming and